Good afternoon, everyone. Am I audible? Am I audible, everyone? Okay. So let's start our today's class. Okay. Okay. So last class we were discussing about the I think the chemical characteristics we were discussing. If I am not wrong, we were discussing about the chemical characteristics, and we have completed mm, up to your dissolved oxygen. Okay, if I am not wrong, as far I remember, we have done up to the dissolved oxygen part. Okay, so next is your chemical oxygen demand and biological oxygen demand. Okay, before that, I would like to say that during this puja holidays, okay, since there will be, you will be getting some, I think 5 days or something like break. So during these days, the module 3, okay, that is about your pollution chapter. So pollution chapter, I don't think there is anything needed to be explained. Okay, it's all the basic things like or about general science. So you can study the module 3 by yourself. Okay, so what I will do, I have prepared one the notes from the Google itself. I have just created some notes. So I will be sharing the module 3 chapter with you all. I will share the PDF, and you can go through that notes also, or if you want to write something by yourself, or you want to prepare something by your you want to search by yourself in the net, then that is more far better. Okay, but the thing is that module 3, it's nothing to be explained about air pollution and noise pollution. Okay, so air pollution, noise pollution, basically everyone knows, like what are the sources, how it can be controlled, what are the preventive measures, what are the effects, so all these things. Okay, so properties of air, components of air, so all these things you I have prepared it in the notes. So if you also want to prepare by yourself, you can do it. So module 3, basically I will give you the PDF. Okay, so from there you prepare for the exam, whenever you will have exam. So if you see that PDF, then it will be fine. Clear? So module 3, I will share it by today. Okay, and other modules I will be going through. Okay, after puja. So let me. I have for that I have to complete this module 2, but module 2 is very long. Okay, so I need some time to finish this. Okay, no ways. Let us come back to chemical oxygen demand. So basically, chemical oxygen demand and along with chemical oxygen demand, one more name is related, that is your biochemical oxygen demand. Okay, so let me explain this two together. Okay, so actually, biochemical oxygen demand, it is what it gives you from the name itself. You understand that it is something, the demand of oxygen. Okay, so it is biochemical oxygen demand or chemical oxygen demand. So COD and BOD, it is something that is the need of oxygen. So what it gives us actually, the organic matter. Okay, the organic matter which are present in the sewage. So that organic matter is basically of two types. One is your biologically oxidized, or you can say biodegradable organic matter. Okay, and the other one is biologically it is not oxidized. Okay, it is not biologically oxidized, and it is also known as your biologically inactive or non-biodegradable matter. Okay, one is your biodegradable matter and the other one is non-biodegradable matter. So your COD test, okay, the COD test, that is your chemical oxygen demand, what it gives us is that it gives us the, the total of your this both the active and the inactive organic matter. Okay, it gives us both the biodegradable organic matter, and along with biodegradable it also gives us the amount of non-biodegradable organic matter. Okay, so when we test COD gives us the two, but BOD it is somewhat more specific than COD. So why it is more specific or why it is more important than COD is that actually in any purpose in any field, what we always need is that we need something. We are always interested in somebody which is who is active in something. Okay, like we don't like the fat peoples, or we don't like anything which is inactive. Okay, everybody likes the active ones. So what this BOD or the biochemical oxygen demand they do is that they are only interested in giving us the result of only the active organic matter. Did you understand what they say? So this biochemical oxygen demand, they only give us the, while we test the organic BOD test, while we do, they give us the only the biologically active, or you can say biologically degradable organic matter to us. Okay, so basically for that reason your BOD it is more important than your COD. COD test gives us the two results, but your BOD they give us only the biologically active organic matter. It tells us how much amount of biologically active organic matter is present in the sewage. Clear? So now your BOD, it has, while you test the BOD, it has a like a standard day, and a standard temperature. So what is that standard day and temperature for in which you do the BOD test? So that is your while you do the BOD test, it is your 5 days at 20 degree Celsius. Okay, you see this line. The BOD of water during 5 days at 20 degrees Celsius is generally taken as the standard demand. Okay, and it is about 68% of the total demand. And what is a 10-day BOD? If you keep the sample for 10 days, then it will be about 90% of the total demand. Okay, so your standard, if somebody asks you what is the standard BOD, then you will say that the BOD of water it is no, it is taken at 5 days at 20 degree Celsius. Okay, so this is about your BOD. So BOD and your COD test, it both can be performed in the laboratory of environmental engineering. So we also in our college also we have the BOD and COD apparatus we have. Okay, so later when you get chance, you can see the BOD and COD apparatus there. Okay, so next is your let me see. Okay, so there is a BOD formula. Okay, so this is the BOD formula. You can see BOD is or BOD 5. Why is this 5? Because the standard it is taken in 5 days. Okay, so it is BOD 5, or else you can write BOD same thing. So is it is equal to DO consumed in the test by the diluted sample. What is DO? DO already we learned in the last class. It is your dissolved oxygen. Okay, dissolved oxygen that it is present in the river or in any water course, it is present there. Okay, and it is important for what? It is important for the aquatic animals. Okay, animals or plants, whatever you say, but it is important the dissolved oxygen. It is very much important for the survival of the aquatic animals and plants. So, if the DO consumed in the test by diluted sample, it means how much of DO it is lost during the experiment. That means the loss of oxygen. DO consumed in the test by the diluted sample, it also means that the loss of oxygen happened during the test. Okay. So, A multiplied by volume of the diluted sample divided by volume of the undiluted sample. So this factor again, this numerator and denominator both, okay, volume of the diluted sample divided by volume of the undiluted sample. So this whole factor, it is also known as your dilution factor. Okay, only this part. Okay, only this part. It is known as your dilution factor. So let me give you one example. It is already given here. Suppose somebody says you that you are given 1% diluted sample. Okay, it is told that 1% of diluted sample is given to you. So what this does this mean? Okay, so it means that you have 1 milliliter of sewage. Okay, you have 1 milliliter of sewage, or you can say the raw sewage sample, and it is the 1 ml of raw sewage. It is diluted to, to make it 100 ml of test sample. Okay, that 1 ml of raw sewage or raw sewage sample, it is diluted, by adding some distilled water, and then it is diluted to make a 100 ml of test sample. Okay, so
Tama?
for this
I have six packs. That's six packs.
okay, muted. Okay, so this if we go to write down this 1 ml of sewage, it is diluted to 100 ml. So how will you write in this formula? So it is first, this the numerator is what? It is volume of the diluted sample. That means how much it is, how much you have diluted. It is 100. Okay, so it will be here 100. Okay, then volume of the undiluted sewage sample. So what is the volume of the undiluted sewage sample? It is 1 milliliter. So divided by, it will be 1. So what will be the dilution factor? What will be the dilution factor? It will be 100. Here it will be 100. So like this, some numericals are there. Okay, so let us see one of the numerical, then it will be more clear to you. Okay, see this numerical 7.2. See this numerical. It is written here that if 2.5 ml of raw sewage has been diluted to 250 ml, and the DO concentration of the diluted sample at the beginning of the BOD test was 8 milligram per liter and 5 milligram per liter after 5-day incubation at 20 degrees Celsius, find the BOD of the raw sewage. Okay, so here in this question, it is given the volume of the raw sample and the volume of the diluted sample. Okay, so now they told us to find out the BOD of the raw sewage, and just now we got the formula for BOD. Okay, so what was the formula? The formula was this one: BOD of sewage, it is equal to loss of oxygen. Just now I told you that it is written there that DO, in that formula it was written that DO consumed in during the test. So what does that mean? DO consumed means loss of oxygen. So same formula. Okay, either you can write that formula also, this formula also, same thing. Okay, so now dilution factor you need to find out. Okay, so just now we got the formula for dilution factor. It is what? Volume of the diluted sample divided by volume of the undiluted sample. So here dilution ratio or dilution factor, same thing. Okay, so dilution ratio or factor, it is 250 by 2.5. So 250 is the diluted, and 2.5 is the undiluted. So what is the dilution factor you got? It is 100. Clear? It is 100. So now we need to find out the loss of oxygen. So how you find out the loss of oxygen or loss of dissolved oxygen? It is you have to subtract the DO or the dissolved oxygen before the test and after the test. Okay, so when you do the you are keeping the sample, sewage sample, in the incubator. Okay, in the incubator at 5 for 5 days and 20 degrees Celsius. Okay, so before the test, obviously the DO content, it will be more. Okay, so after you incubate it and after that it has lost its DO, also obviously the DO content after the incubation period, it will be somewhat less than that before. Okay, so in the question only it is given that the BOD, or sorry, the diluted sample, the DO of the sample before the testing, it is 8, and after the testing, that is your 5-day incubation at 20 degrees Celsius, it is your 5 milligram per liter. Okay, so now you subtract the both, 8 minus 5, so you will get the loss of oxygen. So you put this 3 milligram per liter in the formula and you multiply it with the dilution factor, and you will get the answer as your 300 milligram per liter. So it's a very simple numerical. I hope it's clear to you all. Okay, if you need a further 2 minutes to again see this numerical, you can see it. Okay, you see and then you understand. Understand. I have already explained. So if you want to see it again, you see. Okay, I'm giving you 2 minutes. Okay. So I hope the numerical is clear to you. It's a very simple one. Okay. So let's go back to our discussion. Okay. So now you are clear. Now you are more clear to you. It is clear to you about the dilution factor. Okay. So now, okay. So now you have to know two terms. That is your carbonaceous demand, and one is your nitrogenous demand. Okay. What these two mean? So if you in the sample, okay, the sample, if the oxygen supply, okay, if the oxygen supply, it is made available for 5 days, you can say, or more than 5 days, if the oxygen is supplied, then what it is found that the oxygen, it is for the first 6 or 7 days, it is consumed very rapidly. Okay, the organic matter, it consumes the oxygen very rapidly, and then again for about the end of 20 days, at the end of 20 days again it slows down. The consumption rate, it again slows down. Then again after a few days, it again, what happens, it again slow down to a very low rate. Okay, so the demand, okay, the demand during the first 20 days, okay, which the demand for the first 20 days, which is occurred due to the oxidation of what organic matter, that demand is known as your carbonaceous demand, or you can say the first stage demand, okay. And the next one, the next one, when the it slows down, okay, when the consumption rate it slows down due to, you can say, the biological oxidation of ammonia. So when it is due to the biological oxidation of ammonia, so that demand is known as your nitrogenous demand, or also you can say as your second stage demand, okay. So basically everyone is interested in the first stage BOD, okay. So for the first stage BOD or the carbonaceous demand, we have one, you can say, like, expression, okay, we have one expression. So for that, we need to do one derivation. So let us see that one. So for the first stage BOD, we have a curve. You can see this, graph or curve, you can say. So this curve, it is known as your first stage BOD, okay. This curve is known as your first stage BOD curve, okay. This one from here to here, okay. This whole curve, it is known as your first stage BOD curve. What is in the x-axis? That's in the x-axis, it is time, okay, and time in days, and in the your y-axis, that it is your amount of organic matter that is present in the sewage, okay. So what is this point? This point from where the curve it just has started to go down, this part is your LT. So what is LT? LT is the amount of organic matter. So here at this part, they have taken the condition that at LT is equal to L and your T is equal to 0. Obviously here your T is 0. Okay, at this point your, at this point, at this point when the curve just started to go down, this point your T is 0, that is at the start of the oxidation process. So at that point your LT is, it is taken to be L, capital L, and your T is equal to taken as 0, okay. So now let us see how the derivation is started. So it is said that, okay, it is actually said that the uh, the amount of organic matter, okay, the amount of organic matter, or the, you can say, the rate of deoxygenation. So what is the rate of deoxygenation? It is your dlt dlt by dt. This is known as your the rate of deoxygenation. And what is rate of deoxygenation? It is, it depends upon the temperature, okay. This rate of deoxygenation, it depends upon the temperature, and it also depends upon the nature of the organic matter that is present in the sewage at that time. Okay, so the rate of deoxygenation, it is said to be proportional to the amount of organic matter present in the sewage. So if it is said the rate of deoxygenation, that is DLT divided by DT, okay, it is proportional to, what? Again, rate of the amount of organic matter. So amount of organic matter is taken to be LT. Yes. So if it is proportional, now we have to remove the proportionality sign, and we need to enter one proportionality constant. Okay. So if we remove the proportionality sign and if we enter one equal sign, so there will be one constant, and that is constant is taken to be K. Okay. K L T. Clear? So now let's see what these things mean. Okay, what is this K, or what is this LT? So all this thing you know only, but then also LT is taken to be the oxygen equivalent of carbonaceous oxidizable organic matter present in the sewage. is, or same thing, it is also known as the amount of oxygen, amount of organic matter, that is oxidizable by your carbonaceous oxidizable organic matter. It is present in the sewage and it is taken to be LT. Okay, and T is your time in days. And what is K? K is your rate constant. It is your rate constant signifying the rate of oxidation of the organic matter. Okay, so now after your this step, what they did, they brought the LT here, okay, and they have shift the DT to this side. Okay, they have brought the LT to left side and this DT to right side. They have just cross multiplied it. Okay, so after cross multiplying, you will find the equation as like this. Okay, so after cross multiplying, after you found the equation like this, so they have now integrated both sides. Okay, so after integration, so integration of 1 by something, integration of 1 by something. Okay, suppose it is LT, like this LT, and it is DT, right? So integration of DLT, it is DLT. So integration of something 1 by something is what? Log base of E. Okay, log base of E upon something. So it is log of base E in into your LT. Okay, so now K is constant, so K will go out. It is minus of K into T. Okay, one more thing I forgot to tell you, why this minus sign is here, because the curve is continuously decreasing. Okay, for that reason your minus sign has come here. Okay, so now, okay, so after the minus sign, it has come here. So after you got this equation, log of E LT is equal to minus of KT plus C. So here we have again taken the condition that when your T is equal to 0, your LT is equal to L. Okay. So here what we need to do is that your you need to put this condition. Okay, you need to put this condition into your this equation. Okay, so when you will put these conditions into this equation, you will get the value of C. Okay, then after getting the value of C, you again put this C value in this equation. Okay, so let us see in the next page. See here, so after you got your C value, they have again put it in that equation, and finally after solving, you will get the value of log of 10. So they have converted the log base E, okay, log base E to log base 10. So we have learned in our smaller classes that whenever we convert the log base E to log base 10, so what we do, we multiply a factor known as 2.3. Okay, so they have multiplied the factor 2.3 and they converted it to log base 10, and you will finally get one equation to be like this here. So this 0.434k, so this 0.434k, they have taken it as kd. Okay, they have taken it as kd. So this kd, it is also known as your deoxygenation constant, or also you can say as BOD rate constant. Okay, so now you write this 0.434k as your kd. So if you write again log of 10 LT base L is equal to, in the place of this one, you can write minus kd into T. Okay, so now you take this logarithm to this side. You take this log, you take this log to this side. So what will happen? It will be 10 to the power minus something. Okay, so finally you will get this equation. Okay, so now here L is the organic matter present at the start of the BOD reaction. So And LT is the organic matter left after T days. So, suppose this is the sample you have taken before your testing, the organic matter was F. Okay, now you have incubated it and you have kept it for 5 days at 20 degrees Celsius. So after the incubation, the LT, the what is the amount of organic matter present after T days? It is your LT. Okay, so now you have to find out the how much quantity of organic matter it is present or it is oxidized. So you have to subtract it. Okay, just now the numerical we have done there. So we have subtracted it. So here also same thing. You subtract both the organic matters. So it is your L minus LT. Okay, so you can see the or you can say the BO content also you can say. So it is L minus LT. So now they have again included here one term, it is YT. If YT represents the total amount of organic matter oxidized in T days, so this LT by L, this LT by sorry L minus LT, it is equal to YT. Okay, so YT they have taken it to be the quantity of organic matter that is oxidized in T days. Okay, so this is one equation they got. So now after simplifying, okay, after simplifying again, so finally after simplifying you will get this equation. YT it is equal to L minus 1, L in bracket 1 minus 10 to the power minus KD into T. So this equation, it is your, what is this equation says, you see, this is an important equation. YT it is the oxygen absorbed in T days, BOD of T days. Okay, so the ultimate first stage BOD. So again you can find out, so that is your first stage BOD equation. Okay, so this one we are doing the expression for first stage BOD equation. So this equation, it is your first stage BOD equation. Okay, so now you can again find out what is the ultimate BOD. Okay, so what will be the ultimate BOD that you will be getting? So for the ultimate BOD, you don't know the time. Okay, we don't know the time. Time can be indefinite. Okay, it can be infinite because we don't know after how much time you will be getting the ultimate BOD result. Okay, you don't know that. So for that we put that in place of T, we will put infinite sign. Okay, so here in the same equation like for the first stage BOD equation just now we got, in that equation we will be putting in place of T your infinite sign. Okay, in place of T you will be putting the infinite sign, and finally after solving you will get the expression as YU is equal to N. So this is your ultimate first stage BOD equation. If in question, you have to read the question properly. If in question it comes that you have to find out the first stage BOD equation, you have to find the expression of first stage BOD equation, then you need to do up to your last equation. Okay, up to here. Clear? Up to here, it is your 7.16. It is your first stage BOD equation. And if it is told that you need to find out the expression for ultimate BOD equation, then you need to do up to equation number 7.17. Is it clear to you? So this equation, I know that it is not possible to make you clear with this virtual, like showing you a PDF and you can understand. But then also, it is not that tough if you know integration, if you know logarithm. So everything is will be easy. Okay, for that reason, you please go through this expression or you go through this derivation one more time in your copy. You note it down with your own, no, like you in your copy, then it will be clear to you. Okay, and this first stage BOD and ultimate first stage BOD equation is very important throughout your lifetime. Okay, so you need to know the derivation plus the expression. Clear? So let's end the class today here. Uh, Let me take your attendance quickly. Roll number one,
Yes, ma'am.
roll number two, three,
Present, ma'am.
four, five, six, seven,
Present, ma'am.
eight. Roll number eight, seven. Please mute your mic. Okay. Roll number eight is not there. Seven. Please mute your mic. Okay. Eight is not present. Nine.
Present, ma'am.
Okay. 10, 11, 12.
Present, ma'am.
11.
Okay. 11 is present. 11. Okay.
Yes,
12.
ma'am.
You are 11. Okay. 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 12 is present. 13, 14, 15.
Present, ma'am.
Roll number 14.
Yes, ma'am. 14 present.
Okay. 15, 16, 17,
Present, ma'am.
okay, 18,
Yes, ma'am.
19,
Yes, ma'am.
20,
Present, ma'am.
21,
Yes, ma'am.
22,
Yes, ma'am.
23, 24,
Yes, ma'am.
25,
Present, ma'am.
26,
Present, ma'am.
27, 28, 29. Okay, to is present. 7:30.
Present, ma'am.
Okay. 31, 32,
Present, ma'am.
33,
Yes, ma'am.
34, 35, 36,
Present, ma'am.
35
34.
present.
34. 34.
34 present. Okay. 35, 36, 37, 38, 39, 40,
Yes, ma'am.
41, 42, 43, 44, 45,
Present, ma'am.
okay, 46,
Ma'am,
Yes, ma'am.
41.
41, okay,
Present.
okay,
Yes, ma'am.
46,